for joining us. Today we're going to get into some right-angle trigonometry. We're going to use the trigonometric relationships of acute angles and triangles. We are also going to determine the side lengths of right triangles by using those trigonometric functions. Yes. So a trigonometric function is a function whose rule is given by a trigonometric ratio. Lots of trigonometric talk here. So you're going to see the Greek letter theta. It looks like a zero that's wearing a belt, right? It's like the symbol for, it's essentially like x, right? But it's to use measures of acute angles. You'll see it a lot. So you've all heard sine, cosine, and tangent at some point in your life, probably in Algebra 1, probably also in geometry. You find the sine of an angle by doing the opposite over the hypotenuse. And we'll talk SOHCAHTOA on the next slide here. Cosine has the adjacent side, which is the side touching it, over the hypotenuse, the longest side, and tangent is the opposite side over the adjacent side. Let's get at it. You'll see what I'm talking about here in a moment's time. Let's see. Okay, next slide. Find the value of the sine, cosine, and tangent functions for theta. So if you look, here's our angle theta. The opposite side would be this side with 15. The adjacent side is the one touching the angle. We always know the hypotenuse is the longest side, and it's across from that right angle. So then the other side that's touching the angle is the adjacent side. So it's all based on which angle you're looking at. So we have SOHCAHTOA. Now, my grandmother, she had a cure for everything. She was an older Italian lady, and I would say, Grandma, I think I got a cold. And she'd go, grab a bucket of hot water and soak a toe, right? And I would soak my toe in that water and heal, right? I'd be like, Grandma, please, I have an itchy back. And she'd be like, hey, get yourself a bucket of water and soak a toe, right? So that's probably where this is rooted from, I think. I don't know. Find the value sine, cosine. So sine of theta would be the letters, opposite over hypotenuse. So the opposite side of that angle would be 15 over the hypotenuse, 39. Now, you always reduce those fractions. They're both divisible by 3. So 3 goes into 15 5 times, and 39 13 times. So there's the sine. 5 over 13. The cosine of theta is the adjacent over hypotenuse. So the adjacent side was 36. The hypotenuse was 39. Again, both divisible by 3. 36 divided by 3 is 12. 39 divided by 3 is 13. Not 39 again, Joshua. Mr. Plant, I mean. Sorry, you're not supposed to know my first name. The last one, tangent of theta is the opposite side over the adjacent side. The opposite side was 15. The adjacent side is 36, both divisible by 3. 3 goes into 15 5 times, 36 12 times. So 5 over 12. Never forget what my grandmother Dorothy once told me. Oh, you're feeling sick? Soak a toe, all right? Soak it in some hot bath water. So I'm going to pause it here. I'm going to start the next video. I'd like you to try to find the sine, cosine, and tangent for theta on this one, and we'll go over it on the next video.